Okay, so I'm going to make a parallelogram from diagonals only. So I'm going to say one point. I'm going to click on segment up here, click on one point, and then the other. So this is going to be one of my diagonals, and I'm going to have another one here. And I'm just trying to make a parallelogram. Well, the one thing I know about parallelograms is that the diagonals have to bisect each other. Now, the interesting part, you might say, well, let me use the perpendicular bisector. But I didn't say the diagonals had to be perpendicular. I just said they had to bisect each other. So that means they meet at a midpoint. So I'm going to click here and find the midpoint. Now I could do a perpendicular bisector, and I'd have this line here, and then I'd find that point, and then I can do anything else going around that point. Now the other part I'm going to do is I'm going to create a circle. And I don't really need a compass because I don't need both diagonals to be congruent. If I did, I might measure from here to here and then create the circle that goes around it. But my diagonals just have to be bisected. So the reason I'm doing a circle tool, I'm going to click on C and then anywhere out here, is that I know all that has to be true is that the diagonal is going to go through the circle, through the center. So I'm going to create a line, and I'm going to go ahead and click on D and then C. All right. So that's one endpoint of my diagonal. So why did I make a circle? Well, if I hadn't made a circle, let's say I go back, and I'm trying to do a diagonal, I say, okay, it's got to go through point C. In fact, I can do that. Let me just do a line through point C and some other point. Okay. So there's my diagonal. Don't really need the circle right now. The question is, where does my other point go on the diagonal? Well, if it's going to bisect each other, that means C has to be the midpoint between D and this other point. One way I can do that is by creating a circle between these two. And I can do a compass. The compass will work just as well. And I can do a circle. Now I'm going to find out where it intersects. So I'm going to click on this diagonal that I added in and then click on the circle. The only bad part about this, I'm going to click move, is this point E, the new one, goes right, oops, hate it when I do that. And let me find my construction. Back, 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 back. Here we go. So this point E, I don't really need to see. So there we go. All right, so if I connect, I'm going to hide the lines and let me click View in Algebra, because that's a nice way to hide things. Look for my line and just click on that. And I don't even need my circle anymore, my conic. I'll click on that and hide it. And I'll just do a segment connecting these two. So this should, because this diagonal's cut in half and this diagonal's cut in half, I should automatically have a parallelogram. How can I tell? Well, if I go ahead and connect it, actually, let me do a polygon. So click on the polygon tool, click A, then your next point, there, there, and then go back and click where you started, and that's your polygon. And if I click on my segments, you can see these red segments here. I have several congruent segments, and what I'm going to do is right-click on it to do the properties and say, show me how long you are. I don't need the name, just the value. And it looks like I have to do it for each one. So show the value, show the value, and show the value. So you can see the opposite sides are automatically congruent for the parallelogram because the diagonals are bisected. If I did not have diagonals that bisected each other, let's see, I can adjust point C and F. I erased the wrong point. I want point D on there, not point E. There we go. So now I can adjust this, and it will always be a parallelogram. Opposite sides will be congruent. So when I test your other constructions, I want to be able to adjust only 1 or 2 or 3 points at maximum, because the other point should be set based on the properties of the diagonals.